Hey gang, today we're going to be checking out another type of transformations called reflections. So yesterday we worked on translations and that's like a slide, you're moving things up, down, left and right, you're sliding it or translating it across the coordinate plane. Today we're looking at reflections, which is exactly like it sounds. Think of a mirror and your x and y axes are the mirror and you're showing the reflection of the shape over the line. The mirror image produced by flipping a figure over a line is called a reflection. The line is called the line of reflection. To reflect a shape over the x-axis, you're going to change the sign of the y coordinate. And to reflect a shape over the y-axis, you're going to change the sign of the x in the coordinate. So let's try these. For triangle ABC with vertices A, 4, -5, B, 1, -2, and C, 5, -1, it's reflected over the y-axis. Where are the vertices of the new triangle? So since it's reflecting over the y, we're only changing the x. So A is going to become A prime, which is now going to be -4, -5. And that's because you're only changing the sign of the x when you reflect over the y. Same thing for b. B is going to become b prime, and I'm only changing the sign of the x, so it's going to be -1, -2. You're going to do c on your own. Then 2, that's a quadrilateral DEFG, has vertices D, -2, -5, E, -4, -5, F, -6, -1, and G, -3, -1, and that's reflected over the x-axis. So since it's reflected over the x-axis, we only change the sign of the y. So for D, that's going to become D prime, and if I'm only changing the y, it's -2, +5. E is going to become E prime, and if I'm only changing the y, it's going to become -4, +5. So you can try F and G on your own. Check in with me so I can be sure you've got it before moving on to the rest of the lesson. So now let's try to do some reflections. Starting with graphing TRAP for trap. So we have T is at -6, +1. So that's left 6 and up 1. R is at -5, 5. So that's left 5 and up 5. A is at -2, 5. That's left 2 and up 5. And P is at -1, 1. So that's left 1 and up 1. And we're going to reflect that over the x-axis. So remember, when we're reflecting over the x-axis, we change the sign of the y. So I'm going to rewrite them. T prime is going to become -6, -1. R prime is going to become -5, -5. A prime is going to become -2, -5. And P prime, the one they're asking for, is going to become -1, -1. So you can kind of think of it as reflecting. So this T reflects to here, which is the coordinate they said it should be. This P reflects to here, which is the coordinate we say it should be. And then this R is going to come down 5 here and be here, which is at -5, -5. And then A is going to come down over here at -2, -5. Now, I don't want to keep those arrows in my drawing because it doesn't look very neat, and you wouldn't put that on a test question or an example that you're working on. I just wanted to show you how it worked out there. So now I can draw my new shape, and you'll see that it is the same exact shape we have up top. It's congruent. It's just flipped upside down. Kind of like I'm looking into a mirror or looking into a pond at myself. This trap is looking down at itself over the x-axis. So we have a reflection. Then we're going to take that trap and reflect it over the y-axis. Since we're reflecting over the y, we only change the sign of the x. So T double prime now, because we're doing something twice, is going to become 6, -1. R double prime is going to become 5, -5. A double prime is going to become 2, -5. And lastly, P double prime is going to become 1, -1. Reflecting over the y, only changing the sign of the x from the points above. So now I'm taking these points and moving them over this way. So P double prime is going to be here. T double prime is going to be here. A double prime, right now it's 2 away on the left, it's going to be 2 away on the right. And R double prime. It's 5 away on the left, now it's going to be 5 away on the right from the y-axis. So now we have our third shape that is just a reflection of that original shape once over the x-axis and then twice over to the y-axis. All right, so hopefully you're understanding what a reflection is. It's really not that hard. You're just finding the mirror image over the line that they're asking you to reflect it over. Complete number 4 on your own. So now in number 5, we want to explain the sequence of transformations that brings TRI to T double prime, R double prime, I double prime. So it's similar to what we just did in the earlier problems. So this is my original, and they want to know how I got to this one. So we obviously went over this axis and then over this axis. So we could say triangle TRI was reflected over the x-axis, nope, the y-axis, and then over the x-axis to get triangle T double prime, R double prime, I double prime. So it's important that you can be able to recognize that as well and call it a sequence if more than one thing is occurring. Okay, and then number 6, we have some algebra to look at. The area of a rectangle is given as 10 less than 3 halves of a number. The rectangle is reflected over a line. The new rectangle's area is given as 5 more than 3/4 of the same number. Find the number and the area of each rectangle. So again, we have 2 rectangles and it's reflected over a line. So we know that when we have a reflection, the 2 shapes are exactly the same or congruent. And since they're congruent, they are equal to each other. So the first one is 10 less than 3 halves of a number. And the second is 5 more than 3/4 of the same number. So we can create our equation by setting them equal to each other. So 3 halves of x minus 10 equals 3/4 of x plus 5. We're going to subtract 3/4 from both sides because I know it's smaller than 3 halves. So 3 halves can be changed to 6/4. And 6/4 minus 3/4 is 3/4. X minus the 10 now equals 5. Add 5 to both sides. And 3/4 of x equals, not add 5. Ooh, Miss Kiesler did something that you guys typically do. Plus 10 equals 15. Multiply both sides by the reciprocal, gives me 4/3. And I get x equals 15 divided by 3, which is 5, times 4, which is 20. So we have 20 as x. Now we got to find the area of both. So we have 3 halves of 20 minus 10. 20 divided by 2 is 10, times 3 is 30 minus 10. And coincidentally, it winds up being 20. Let's see if the other one is also 20. So 3/4 of 20 plus 5. 20 divided by 4 is 5, times 3 is 15, plus 5 is again 20. So their area is 20 units squared. All right, so again, whenever they're asking for an algebraic kind of question dealing with translations and reflections, they're just going to be equal to each other because a translation and a reflection does not change the size or shape of an object. It just moves it around the coordinate plane. Okay, with that said, you're on your own